Jaishankar sir, shall we start?
Whether Thomas sir is ready? If Thomas
Yeah,
sir
I'm here, sir.
Yeah, okay, sir. So let us start now.
Sir, able to see me now?
Yeah, we are able to see you. Okay, we can start now. Almost 24 members have already joined. We will expect more members soon. Welcome all engineers to the 60th webinar of KSEBEA Engineers Association. Today's topic is transformer oil and its PCB contaminations. As you all know, polycarbonate biphenyls contaminations affect human and it is cancerous and it affects environment also. Today, Dr. P. Thomas, head of Dielectric Material Division CPRI, is handling the session. On behalf of KSEBEA Engineers Association, wholeheartedly welcome Dr. P. Thomas to the webinar program. Over to Dr. Thomas sir for the session.
Thank you, sir. Thank you for a nice introduction. I hope you're all able to see me.
Yes, sir. Yes, sir.
Your slides are visible?
Yes, visible. Yes, visible.
Okay, sir. So I like to thank you for giving this opportunity. It is our pleasure to talk about the subject because this is a very important subject where there should be awareness about PCBs also. So I like to thank you for taking this step. And in CPRI, we have conducted more than 100 such programs over the years so that people will be aware of what is PCB contamination. So today I will be talking about the management services for treatment of transformer oil containing PCBs using our mobile dechlorination system. So here I will talk about what is PCBs and then what is the toxicity of the PCBs, why we are talking about the PCBs, and then what is the necessity for talking about the subject and how to go about this PCB dechlorination in the India. So to start with, so if you look at PCBs, this is a chemical synthetically prepared. It is not just like the naturally available. It is a synthetically prepared chemical. So before that, I would like to tell you, you all know about transformer oil. The transformer oil is derived from petroleum crude. So when the petroleum crude comes, you know, you do all the fractional distillations. You try to get petrol, diesel, and so many things. There's one particular compound called transformer oil base stock or feedstock, we call it. So that transformer oil base stock is the one which is used for making a transformer oil. It's called mineral oil. We call it mineral oil. We call it insulating oil. Okay. So this is a petroleum-based product. But apart from that oil, there are so many other oils have been used in transformer oil. Transformer for insulating purpose. For example, I'm not going detail into this. I just want to give you some view. So there are oils called silicone oils. There are oil called synthetic esters. Nowadays, you all know about vegetable esters, synthetic esters, and earlier they were using silicone oil. There are some still transformers are in having silicone oil used in transformers, and there were some hydrocarbon oils, high hydrocarbon oil. They call it high molecular weight hydrocarbon oils. Like that, there are many oils are used in transformer application as a insulating purpose. So PCB is a one compound which is also been used in transformer as a transformer oil. When you talk about PCB, if you look at this compound, it's actually a solid material. So when you see this structure here, there are so many chlorine atoms here, hydrogen atom here, and depending on this structure, so suppose if you look at this structure, this is one compound. Like that, there are 209 compounds of mixtures are there. When you talk about the PCB, it's polychlorinated biphenyls. This is one such compound. By changing, the chlorine atom will come here, that hydrogen atom will go there. Like that, chemically they can modify and find out. They can have 209 individually chlorinated compounds. So they call it congeners. So all these 209 compounds to put together, they call it PCBs. So when you talk about PCBs, these PCBs are all man-made organic chemical. It is a solid material. And I'll come back to that in a couple of slides. This has been used in a transformer as a transformer oil by mixing with the other compound. As a solid cannot be used, so they added some other chemical. They're mixing it, they're used. So here, all 209 compounds are not present in the PCB soil. So depending on the country, depending on the manufacturing place, there are some PCBs. So group of PCBs were being produced. For example, if you look at here in this, the number of chlorine atoms and their locations PCB molecule determines the many physical and chemical property. So if you look at 1242, 1254, 1260, I have mentioned here. If you look at in this slide, 1242 means there are some 42 components out of 209 compounds. The 42 components are put together called one type of PCB oil. So this is again further modified, added with other solvents and made as a group of oils. Similarly, 1254 means there are some 54 components out of 209. Some 54 components are made into this thing. But sometimes what happened, the 1242, 1254, there are some compounds present in 1242 also will be present in 1254. There are compounds present in 1254 also present in 1254, 1242 and 1260 also. So this is what, if you look at PCBs, there are some, either it can be 42 chemicals, all chlorinated compounds are put together called PCB oil, or 52 components or 60 components. So there is no 209 components present in one single PCB oil. So these PCBs are used in transformer for transformer application as a insulating oil. But these PCB oils are if you look at here, these are the chemicals. I'm just giving you some idea. So there are so many chemical structures you see here. Chemical names are there. By adding a chemical, there are 209 compounds, different chemical names, all put together. We call it PCBs. So these PCBs are all have called congeners. But in here, take any PCB oil. If you are having a pure PCB oil, it will not be 100% PCB oil. It will be 40% or 60% like that. But at the same time, in any PCB oil, you will not have all 209 compounds. As I said, 1242 means only 42 PCB compounds are there, 52 compounds are there, 60 compounds are there. So this is as about the PCB. So these PCBs are used in transformer for transformer oil application. Apart from PCBs, there are so many other oils have been used. But here, why we are talking about PCBs? So here you can see here. This type of PCBs 1242, generally they were using it in capacitors as a capacitor fluid. Whereas 1254 and 1260, somewhere around 40 to 60% of this material added with the trichlorobenzene, and they make a formulation, and this has been used in transformers as a transformer fluid. So when you take a oil and test PCBs, sometimes you'll have 1254 or 1260. So in Indian scenario, we have not come across any 1242 in transformer oil. We have come out only 1254, 1260 of PCB oil. So this is about some PCB oil. So here, why we are talking about PCBs? So in organic compounds, one minute. Okay. See here, we call it persistent organic pollutant. We call it POP, POPs. We call it POPs. So these persistent organic pollutants, there are so many persistent organic compounds are there, pollutants are there, and one among them is the PCBs. Because these persistent organic pollutants, they are all organic compounds. They have very harmful characteristics. For example, it has a very persistent. Persistent means once it's get into the body, it will not go. It will be staying like that only. It will not disintegrate. It has low vapor pressure, low water solubility. It will never mix with the water, and it can travel a long distances if it is in air and water current. And then it has acute and chronic toxic effects on human and wildlife. So here, if you see 12 POPs, there are so many POPs, you all know about DDT, okay, SCP, DDT, aldrin. These are the 12 components called POPs. The 12 compounds, all these POPs have been banned in somewhere around 1970 itself. One among them is a polychlorinated biphenyl, which is used in transformer as a transformer oil, which has been banned from 1970 onwards. But today, still we are talking about PCBs because these PCBs are toxic in nature. So it is still being used in transformers, and it is supposed to be eradicated from the system. And there are some commitment has been given to us. If you look at history, these PCBs are manufactured somewhere around 1929, and mainly 60% have been used in transformers and capacitors. And apart from these PCBs, as I told you, it is all solid materials. They make a formulation. It has been used in industrial fluids, gas turbines, hydraulics, and also used as additives. And if you see any paint, you'll have PCBs are there. In sealant, they're using PCBs. So, but mainly we are talking about dielectric fluid where transformers and capacitors, 60% of PCBs are being used. And we never manufactured, India never manufactured this. It has been manufactured in Austria, many countries like France, and even China also manufactured it. In China also, a lot of PCB oils have been manufactured. So now, if you look at this trade names, the PCBs have been manufactured by different various companies, so they have their own trade names. If you come across any such names in your transformer name plates, then you can say it is PCBs, because PCBs, nobody know whether it's what type of oil we are using in transformers. Most of the times when people work on the fields, they don't know what is PCBs, and there are different trade names are given. Sometimes what happens, these PCB transformers are installed more than 40-50 years back. There are still some transformers are working, and people may not know about what is PCBs. They were handling it, and these are the different trade names are there. And whoever come across any such trade name, they can say that this is a PCB oil. Okay. So why we are talking about PCB? Because PCBs are carcinogenic to animals and human, and it has acute exposure to high levels have been associated with eye irritation, skin, and it has dizziness, depression, memory loss, impotence, fatigue, nervousness. There are so many issues are there, and whenever PCBs are contaminated in the water, earlier days, what happened, if you look at, these are the various types of diseases they found out. Finally, they could arrive that this is all because of PCB disorder, PCB contamination. So they have found out various diseases on different people. When they take the samples and check, they found that there are some PCBs present in their body. Sometimes when the people get exposed, their skins started getting these problems. So though it is not internal, it's an external problem. So these are the various toxic effects of PCBs. That is the reason it has been banned in 1970. And after 1970, there are so many countries, they have taken out from this thing. So it is sometimes you see this earlier days, what happened, the PCBs, one may ask, how did the PCB came into this land? Earlier, when there's a leakage in the mineral oil or very leakage in the transformer, they were dumping it in the ground. Sometimes they were also dumping in the ground. They were simply disposing it. So that is how when it goes into the soil, naturally when the rain comes, automatically they will carry to this, and there are some contamination. So we have been working in this on only on the transformer oil part. But there are some projects we have seen. People are trying to find out the PCB contamination in soil and water. And they have taken, there are a lot of reports are there. These PCBs have gone into the soil, and it is contaminated, and people have taken those water, they are getting into a lot of problems. So basically the PCBs are going from this, mainly from the transformers leakage or land filling. Sometimes the transformers are failed and bursted and got into this, leaked into the soil. These are the ways in which PCBs are get into the environment. So later on, only when it is started giving toxic effect, they found that it's toxic in nature, so it has been banned in the system. Okay, so there are a lot of conventions happen, and they talk about this eradication of PCBs in the system because of the toxic effects. As I said, in 1970 itself it is banned, but after that, a lot of conventions happen, and there are so many parties are there, and we are also signing the party. You know that global warming and so many things are happening, and our diplomats go and attend the meetings and come back. They sign the treaty, but still we are having the PCBs are in our transformers, and what to do, how to go about it. In this aspect only, what happened is recently CPRI has been identified as a nodal agency by Ministry of Environmental and Forest, and here there are a lot of environmental projects are there from GEF, that is called Global Environmental Facility. Through Global Environmental Facility, there's a United Nations Industrial Development Organization, we call it UNIDO. Okay, they take up some projects like this, and they go to the countries, different countries. So here, through UNIDO, we have got a project to this India, through again MIF. So MIF and UNIDO are both are involved in this, and they have come out with the interest to start the work. So we have started National Implementation Plan, where we started creating a lot of database. So first phase in CPRI, what we did is we started finding out what are the PCBs, where all PCBs are present. Then second part is that how to destroy that. That will come back to later on. So here CPRI role, when you look at first phase, we have completed. We started somewhere in 2007, and we have completed first phase. And then further, that project has been extended, and we have created inventory. I will come back to you. I will show you how much PCBs are there in the country, and we have returned to the many people. There are some formats are available. We have returned to them, and then we started getting the samples. We started analyzing it. There are so many people, they were not able to identify what is the PCB oil. In those cases, we used to ask them to send the sample to us. So here, as I said, these PCBs are banned in 1970. Okay, but there are inventories could be available because these oils are being imported. So when a person is importing, when a transformer or manufacturer is importing the oil, he might be having a lot of inventory with them. So without telling anybody, he would have pushed into the market and it would have gone into the system. Though it has been banned in 1970, there are chances that PCBs have gone into the system even after 70. There's a import, export, everything. Anyway, we are not exporting it, we are only importing it. Even import has been stopped, but still the inventory would have been there. For that reason, what we did is we have started analyzing all the samples from 85 onwards. Instead of going to 1970, from 1985 onwards, who are all having the PCBs. So we started going through that. We started analyzing the samples, and we have requested all over this country, saying that any transformers installed prior 1985 has to be tested. So like that, we have tested the samples, and we have created a database. I'll show you that. And then second part is that how to destroy this. This is the next part. So I'll tell you that. For example, as I said, we have carried out more than 100 awareness program. We visited many sites, and we have created some guidelines of PCB, how to identify and how to, if any transformer is having a PCBs, how to manage that. If transformer is, say for example, it is old transformer having a PCB mean, then how that has to be contained and how it has to be stored. All the things we have prepared a lot of guidelines. And if you look at here, this is how the PCBs has been tested in all over this our country. So we have characterized, how many transformers in east, west, something like this. Totally, we found that total tons of PCBs are 9,837 metric tons. This is very old data. We are still updating the data. So if you look at mainly the power sector is having the highest number of PCBs, and then steel industries and the cement industries, fertilizer industries, and others. Okay, so total is this much. So here we are characterized like how pure PCB. Pure PCB is not 100%. Okay, pure PCB is uncontaminated. So here, when you are having a transformer with the PCBs, those days what happened? People were not knowing which is PCB or not. So they would have used the same machineries for using the other transformer. So one transformer may be having PCB, other transformers may not be having PCB oil, maybe mineral oil. But when you are using the same filtration plant or machineries and trying to top up here and there, then what happened? This question of contamination came into picture. So when we analyzed, we found that there are some transformers having pure PCBs. There are some transformers having contamination of PCBs above 500 ppm also, below 500 ppm also. So this is contaminated PCBs above 500 ppm only we are taken into account. And there are some stockpiles, like they stored it in some drums and things like this. So finally, we have arrived at some figure. 9,837 metric tons are available in this country. So next step is what to do. So one is that how to destroy that. So there are so many disposal technologies are available. I just made some list here, and here we have gone through all those studied all those technologies. We invited in the UNIDO under the UNIDO project. We have invited so many what do you call it? The disposal people. So we have invited so many people from all over the world. They came and gave a lot of presentations. We have gone through that. We found that, see, they have many technologies are available. Some are viable, some are not viable, some are cost effective, some are very expensive, things like this. So finally, whatever the technology you select, as per the treaty signed, as per the environmental norms, when you try to destroy or when you try to dispose the PCBs, you should not end up with another PCBs, another toxics. You should not give another material. For example, you try to say, for example, if you are trying to burn PCBs, then what happens when you're burning at PCBs? The full PCBs are not being burned. It also start creating other PCBs. The gases, whatever, when you try to, we call it dioxins and furans, which are all PCB compounds. PCB compound, chlorinated dioxin, chlorinated furans are all created. That is become more dangerous than the oil PCBs. So they found that earlier they were not knowing anything, they were landfilling it. Nowadays this has been totally stopped, no landfilling is allowed. And then you are not supposed to burn it also because you are not able to completely burn this. So that's the problem. So there are some technologies called sodium based technology, we call it. So you'll all know that chemistry. If you see that the structure I told you, chlorine is there. So by using the sodium technology, there's a sodium metal and there's something is called. What happens is when you add sodium technology, that sodium will react with the chlorine and will form sodium chloride. So very simple technology. It looks very simple, but it's very complicated. But at the same time, it's highly safe. It is highly you are not ending up with any other toxic materials. You are only producing sodium chloride and totally destroying all the PCBs with it. But the technology is very, very, very expensive. Then what we found that there's something called plasma technology. Okay. So here I would like to tell you one thing. From the inventory, what we have done, we have created inventory. We found that how much oil is present. So here there are some oil contaminated PCB. There are some high-level PCBs. So as per this project here, when you see a transformer with a PCB oil, how to go about it. So what happened is in the project. So as I said, if you look at this inventory, we found that this steel plants are having highest number of PCB oil. So in this 100 window project, the Bilal steel plant has come forward, and CPRI and Bilal steel plant together we are working on this project. Here, what happens is when the transformer is oil with the PCBs are available, if it is more than 10,000 ppm, then it will go to Bilal steel plant. If anything less than 10,000 ppm, CPRI will be doing the work. Okay, here the technology is like, I'll just tell you, if you are suppose you are having a PCB oil. Say for example, you are having a pure PCB oil. How to do that? So this has to be sent to Bilal steel plant. If the oil is having contamination, then I will show you in a couple of slides. I will show you what we are doing. CPRI will do the work. So here the technology is that if you are having a pure PCB oil, there is a technology coming up, Dielectric plant. There's a big plant is coming up. There are various stages are there. One is that you remove the oil from the transformer, and then is something called plasma technology. We use plasma technology for pure PCBs. Why we are using plasma technology? So though is also technology where the oil is being heated, but you are not heating it in a low temperature. Say for example, some people are telling, why don't you use cement kilns where cements are being produced? There are some kilns are there, 1400, 1500 degrees centigrade, we can do it. But we are not able to do it because it is producing other dioxins and furans. So that's the reason that, that we are not supposed to use the technology. So we are using something called plasma technology, where you can see in the graph, the high temperature comes in, and then that light tube where this oil will be flowing. You create a plasma here, the temperature will be somewhere around 3000. So under the 3000 degrees centigrade, what happens is your PCB oil totally disintegrated, and then you see end up with only carbon dioxide, sodium chloride, water. But this is a big plant. It is not simple. So they have so many stages are there to do that. The plant is like this. This is what in coming up in the Dielectric plant. So when you have a pure transformer, first the oil has been treated using the plasma technology. Oil has been destroyed. The second part is that the transformer will be washed with some solvents, so that whatever the PCBs are available, that also will come. And then that contaminated oil, they have another small setup where they use sodium-based technology to treat that. So one is that you are cleaning the oil, you are removing the pure PCB and destroying with this plasma technology, and then the oil, whatever is contamination inside, it will be still in the core and in paper and press boards, oil is still will be there. We use some solvent. Then after that, the transformer is cut into small 2 portions or 3 portions. I don't know. They have a big plant there. Literally, it will cut and remove all the parts. And again, that all those parts will be washed in some solvent so that there's not be any PCBs. Completely, they'll wash everything. Then that all those scraps will be sent out. So this is how the plant is coming up in Dielectric plant. So if you have a PCB transformer, pure PCB transformer, that has to be sent to Dielectric plant. Then they will totally destroy it. Here, I would like to bring to your kind notice that suppose you are having a transformer of say 20,000 ppm, say or 10,000 ppm. What we found that if the transformer is having 10,000 ppm, you may think that we can remove the oil, we can put some new oil and wash it and again put back into the system. But what we found that from the studies, the oil which having 10,000 ppm and above, if you try to do that, and still after some time, after 5 months or 6 months, again the PCBs are coming into the oil. Say for example, you remove the 10,000 ppm oil and you clean with some fresh oil and then put back a new oil and you want to use the transformer. Then what happens is that oil will be still contaminated with the PCBs. So everything should be less than 2 ppm, but it will be more than 50 ppm. That's the reason we found that anything more than 10,000 has to be totally, transformer has to be totally destroyed. You cannot retrofill. Retrofill means you all know that. You remove the oil and clean the transformer, put back a new oil, and you can start using the transformer. That is not possible for the transformer having 10,000 ppm and above. So that is possible only with the less than 10,000 ppm. Of course, there also again we found that it requires a lot of flushing. You have to flush this with the new oil, and then 2-3 times, I think maybe 2 times or 3 times you have to flush. Again, the cost will go up. This is all possible only when your transformer is very, recently commissioned. But if you look at the history of the transformer, any PCB oils, pure PCB oils are much older. Only in the case of contamination. So there's a chances that the newly installed transformer also can be contaminated with the PCBs. If that oil is having contamination, then that oil can be easily removed because these transformers are recently commissioned. So it will not be very high ppm. So what we found is most of the transformers, what we have found, there are some 500 ppm and above, but less than 10,000 ppm. So here, so as I said here, this transformer with the PCBs, the high level PCBs, as I said, pure PCB transformer, all will go to Dielectric plant. The transformers having less than 10,000 ppm, it will come to CPRI. Then what we do is, we call it a contaminated oil. So this contaminated oil will be taken into some reaction vessel and we add sodium So that we call it sodium dispersion. The sodium dispersion means the sodium metal is reacted, mixed with oil, and we do that some process. I'll show you that, and then you make a dispersion. So sodium and oil will be some 40 to 60%. That you add in the PCB oil, so that whatever the sodium present in the sodium dispersion will react with the PCB oil, and all PCBs are removed, and all chlorine is removed, and all that oil will be regenerated. For example, if you come to this place, so this is the 2 units. We have got it under the project. Under the unit of project, there are 2 systems that come. One is called the sodium dispersion unit. Other one is called PCB dechlorination unit. I will talk about that. So this is, if you look at here, this is a dechlorination unit which is fixed in the vehicle. It will be taken to the site wherever oil is contaminated with 10,000 ppm, and we can start using the machine, and we can start removing the oil from the transformer, and we can clean these PCBs and see that it is less than 2 ppm, and we'll remove completely the PCBs. Okay, so for that I will tell you how we are doing it, and come to this part. So here, as I said, the sodium dispersion is being prepared here, and the sodium metal and mineral oil is a pure oil free from PCBs. New oil has been taken, and it will react with the reactor, and then you maintain certain temperature, then you get a sodium dispersion. For example, here if you look at, this is a sodium metal we get in a bricks. It comes in a drums, and like this is a sodium metal. And then in this portion, this facility is available in CPRI. Installed in CPRI. For example, when I show here, this facility is installed in CPRI Bangalore, and this is installed in the van. Okay, so here, using this facility, we make sodium metals. We buy the sodium metals. Inside there is a reactor. There is something called sodium dispersion making reactor. Here we take the oil first, and this oil is heated through heating oil system. The oil is heated here, so that all moisture will be removed. You know that sodium metal is very dangerous. You cannot keep it outside the atmosphere to catch fire. If moisture is fell into this, it will blast. Such a very dangerous material. So first you take the pure PCB free oil, new oil, and having some specification, because when you look at the sodium and the oil, the density is a very important aspect. So we have to select an oil having more than 0.89 density. So we buy only that transformer oil and add sodium and mix it. Here when mixing it, we'll heat the oil first at 120, and then at that 120, we add sodium metal, and the moment you add sodium metal, it will melt, because 115 to 120 sodium metal will melt. Then what happens is both melts together, and then there's something a scrubber here. Then we'll stop the heating, and within the scrubber itself, it start rotating like anything, and somewhere around 15 hours we have to do that. Once you do the 15 hours, and finally you see you have a sodium dispersion. So this is how it has been done, and then we store it in the drums. So they are all adding into the machine, and once, so here I did not bring the picture. So this is sodium metal from the bricks. It goes to a level of 5 to 10 microns. The particle size of the sodium will be 10 micron, 5 to 10 microns. So if it is a 20 micron, 30 micron, what happens? The reaction will not be happening. It takes longer time. When you take the sodium, you understood. I hope you all understood what I'm telling. You are taking a sodium metal, adding an oil, and making a sodium dispersion. So this is in 40-60 ratio. Sodium will be there in a pure oil. So this one you are using it for treating the PCB oil. So when you treat this oil with the PCB is reacted with the sodium. You form, as I said, sodium chloride. All the things happens. So this oil having sodium dispersion, if the particle size is more than 30, 40, 50 like that, then what happens? The reaction is slow. Whereas if it is less than 10 micron, the moment you add the sodium dispersion to the PCB oil, we found that the reaction takes place in 2 hours. And I'll show you here. This is the plant where PCB dechlorination plant is fitted in the vehicle. As I showed you that. Here it has a reaction tank. The reaction tank's capacity is 4.5 KL. So this is a batch process. So when we take the vehicle to the place where PCB oils are there, what happens is that we connect. We have different way of connecting this. First, or the PCB contaminated oil will be stored in a tanker, because it will be in different, you may have it in drums or it may be in a transformer, but we have to first load it to the storage tanks. From storage tanks, we'll directly take it to the reactor here. So as and when we need 4.5 KL, we'll take it. Then this is again, this reaction takes place. Here again, we are heating the oil. Here again, when we are taking the PCB contaminated oil, we'll be taking the PCB contaminated oil here around 4.5 KL, and we will heat it initially, so that whatever the moisture present in the oil also will go. So what we found is it sometimes stored in drums, sometimes stored in transformers. When we found out huge moisture is present in that. So when the moisture is present in that, the sodium will react and it will create a problem. It will not remove the chlorine. Instead of that, it will start reacting the water. It will create a explosion. So we have to remove all the moisture. See that moisture is, you can see literally there's vapors, water vapors are going out. Once the moisture has come down, that then we check the moisture content. Then we have the sodium dispersion. You can see the drum, it is fitted into the van here. Here it is, there's one more portion here, we will fit the van, sodium dispersion here. Then this van is, we add depending on the PCB. For example, suppose I have PCB oil 50 ppm or 100 ppm or 500 ppm. Depending on that, we have a calculation how much quantity of PCB, this sodium dispersion oil has to be added. See, this is a sodium dispersion prepared in a pure transformer oil. So the sodium dispersion here, sodium having a particle size of 10 microns, and 40-60 is the ratio. 40% sodium, 40% oil, 60% is the sodium. That is a mixture we make. That mixture we take it here and add it into the PCB contaminated oil here. When we add the PCB contaminated oil, this sodium dispersion to PCB contaminated oil, when the temperature reaches 120, the reaction takes place. All PCB oils, all chlorinated compounds are reacted with the sodium, and you get sodium chloride, and you also have some other compounds forming. If you look at the structure, we call polychlorinated biphenyl. So once the chlorine is removed, that chemical, the biphenyl will be there. So here, when you add sodium dispersion, the sodium will react with the PCB oil. It will remove chlorine, and sodium chloride will form, and that oil have transformer oil. You have that PCB oil, PCB, because we are only dealing with the contaminated oil. So whatever the contamination is there, that PCBs will convert it into sodium chloride and biphenyl. Rest will be transformer oil. Here, when we are doing the reaction, we always take excess of sodium dispersion, so that the reaction will be complete. So once the reaction is complete, the sodium, excess sodium has to be removed. So here, this technology, though its water is very dangerous, will sprinkle the water. So all these things are done in nitrogen atmosphere. So we carefully add water, slightly will add water, so that whatever the excess sodium present, it will react with the water. When you see the reaction of sodium and water, it will form sodium hydroxide, plus it will also give you hydrogen gas. So this is a very dangerous reaction. So hydrogen will come here. Because it is all controlled, all hydrogen will go, and excess sodium, when it's reacting with the water, hydrogen will be escaped, and sodium hydroxide formed. So finally, in the reaction tank, when the PCB oil is reacted with the, when you treat the dechlorinate the PCB oil, final product will be your sodium chloride, sodium hydroxide, water, and biphenyl, and transformer oil. So this is the mixture. So what happens is, we have a settling tank in the van, within this van. So immediately, within the reaction is over, after that, we transfer it into a settling tank. So once you go to the settling tank, it will be kept for the overnight. So when you keep it for overnight, slowly all those sodium hydroxide, sodium chloride, and water, everything will come down to the bottom, and the top layer will be only of that oil which is free from this thing. Here again, so before doing the reaction and after completing the reaction, we are testing for the PCB contamination level. So we may start with the 500 ppm, then after the reaction, what is the ppm? So here we found that the reaction is complete in 1 or 2 hours, because the reaction is such that we get the reaction completed within 2 hours. And then when we check the oil, we found that all PCBs are removed is less than 2 ppm. So this oil, after this, we remove it in treated oil and we remove. So here, the black portions, something what you call, if you look at here, so this is how we do all the things. You can see here, the PCB decolored oil, once it is in the settling tank, it will be like this. So when you take the oil and immediately put it in a beaker, you can see that in overnight, it settled down like this. So the same thing happens in the settling tank. So the settling tank, is such designed in such a it's a cone type one. So easily the sludge will come down to the bottom, and then we can also slowly remove that. So there's a valve there, and we remove the sodium, that whatever the sludge portions. We remove the sludge portion, then the oil will be separately taken into account. So this oil has been tested and it is free from oil. So this is how the PCB treatment has been done. So this sludge, whatever we remove from after the reaction, this has to be disposed. So it has, as I said, sodium chloride, sodium hydroxide, water, biphenyl, and oil. This sludge generated has to be disposed. So you cannot just like that throw it. It has to be disposed here, authorized recycler who are all doing this solid disposal. So they will take this sludge and they dispose it, and they also give a certificate. So here, the people, those who are authorized by state pollution control boards, are supposed to do this work. You cannot do this to anybody. So this, we have identified one person. So we have done, when we are doing some projects in CPRI, we have disposed this to a authorized fellow. He has taken back, and the oil, we can dispose it out. The oil, whatever is after decoloration, we cannot say, for example, this oil, whatever the oil coming here after the decoloration, this cannot be directly used in transformer, because we are removing the oil only by settling process. So it has moisture. It also will have some particles. So it has to be removed. It can be further treated. So here, when you look at the economics, suppose you have PCB contaminated oil and you removed all the PCBs, the oil is there, and almost some 20% will be of sludge. From 100%, so sludge will be of around 20%. You get only 80% of the yield from the treatment. That 90%, whatever you call it, or 80% or whatever you call it, you can further treat that. So this oil is free from PCB. You cannot be directly used in transformer. Further treatment can be done, but after further treatment, the oil cannot be used in high power transformers. It can be used in distribution transformers. Of course, again, you have to add some additives. But here, the cost of the economics of treatment, further treatment, we have enquired some people. The further treatment takes somewhere around 40 rupees or 30 rupees, we don't know. So once you add the 40 rupees or 30 rupees, then this oil, if you sell it, you are getting 20 rupees by selling it. Whereas if you treat at 30 rupees, so the economics is not working out. We are comfortable in selling the oil as a scrap, and you get back some money, some 18 or 20 rupees you get back. So this is how the oil has been treated. So we have done this commissioning time. We have 36 metric tons have been treated. So that is what I'm showing, that figure where the sludge generated. We have sent it to some fellows. The oil has been sold to some people. During trial runs also, we are treated some 21 tons. And then tangent go, people have sent the oil to CPRI. So we have treated around 23 metric tons. We have visited Karnataka Vishweshwar Iron and Steel Plant. We have treated around 21 tons. Like that, if you look at here, Ardhagan Thermal Corporation from Aligarh, we have treated 122. Like that, totally, recently we have done in Chandrapur Thermal Power Station, where around, this is 80. And anyway, we have done around 140 metric tons we have completed. The total comes around 360 or something. And there is a first phase. The second phase, again, they have around 300 metric tons of oil, same contaminated oil. And we are going to take it up. We have already, that order we are supposed to get, we are getting it. First phase, we have already completed the work. And second phase, again, we are going to take some 300 metric tons. So using this vehicle, CPRI, we are trying to do a lot of projects, and we have successfully done a lot of work. And this is a van, we are taking it. So here, when you look at this van and the truck, the cost towards this, is huge. It drinks a lot of diesel. And then nowadays, this toll charges are very high for this vehicle. There were a lot of problems. They were not allowing the vehicle to go because it's been registered as a non-transport vehicle. But still, they said that it's a multi-axle vehicle. You have to pay more tax. I mean, more VAT charges. I mean, sorry, that fast track charges. So when it reaches a place, fast track charges itself, we are spending somewhere around 30,000 rupees. We have seen that going and coming. And the diesel is, this vehicle will give 1 liter itself. That's what 1 kilometer means 1 liter it will consume. So these are the cost factors. So here again, this unit, whatever this unit we are telling here, this will operate only in 385 degrees because this machine has come from Russia. So this will operate in 385. So we don't want to take a chance of directly connecting to our this thing. So we have a step down transformer where it will, so 385 it will step down. So whenever we go, we carry so many other items. So as I said, that sodium dispersions we prepare in CPRI at Bangalore and take it in a truck whenever we go. So for example, for treating this Harijaganj, say around 140 metric tons, somewhere around 40 drums we have to carry. So 40 drums of sodium dispersion we have carried, and we have some ladders here. You know that the height of the vehicle is so huge. So we have some different ladders here, and then we also have some transformer. All the things go in a different track. So we have to pay for that. That truck also will cost. So that is coming around 4 lakhs. Any that is like a contract. Whether you run for 100 kilometers or 20 kilometers, that flow charges per kilometer charges and retention charges. So it goes very high. So when we take up the vehicle to the site for our diesel and other costs, including everything, comes around 4 to 5 lakhs. So apart from that, we also charge people in 20 rupees per liter. So this is 20 rupees per liter we are charging because, see, in this project, under this UNIDO project, we have, this is only something called a demonstration project. So UNIDO has come forward through MOF, and this has been started. Now, under this contract, we are supposed to treat 750 metric tons. This is a contract. We have the project with the UNIDO and MOF. So this contract will be get over once we complete the 750 metric tons. As I said, already we have completed 360 to 300 metric tons, and another almost half of the oil is there. And once we take up some places, 2-3 places, I think the project will be over. So we have some funds here in this project. That's the reason we are charging only 20 rupees per liter for your treatment cost. Because some of the charges, when we come to the site, there are some 6 or 7 people will be there. And, as I said here, if you look at this, 1 minute. For completing, as I said, it is a batch process. 4.5 KL is the treatment capacity. You can calculate. So for doing one trial, say 4.5 KL, it takes 2 days for us. So in Harijaganj, as well as say for example Chandrapur, for treating 140 KL, they have taken almost 3 to 4 months we have spent. So when a project team goes there, they have to stay there for 4 months. So under this condition, so the utilities, overall having PCB stakeholders, they have to provide us the guest house accommodation. They have to take care of their food, other things. And then we also need a nitrogen cylinders here because it has to be completely in nitrogen atmosphere doing it. So though it is a computer control, because it's computer control, if the nitrogen gas is not there, automatically the plant will be shut down. So nitrogen cylinders are used for batch or something like that. We have a huge number of nitrogen cylinders is required, and then we need a place to store this sodium drums. We bring sodium dispersion in 30-40 drums that has to be stored in a proper place without any water, anything leakage. Plus, when there is a rain, we cannot do this work. So there are so many things are here. So this is a batch process. So it takes time. Say for example, in Chandrapur, we have done, as I said, 140, more than 44 to 5 months. So they have given a guest house for all our people, and they are using their canteen facilities. They were able to do this, and we could complete the work in a very nice way. This is how we are taking care of all our activities. And here and in Kerala also, we have many places where the PCB oils are there, and we are written to the many people, and we are expecting that orders from them. So once orders, we have something called site requirement. Okay, so what are the site requirements? We have our own site requirement. Like now, we need one room for storing the sodium drums. We need people, guest house, everything like this. So this is how we are doing it. We are successfully done, and we are still working on that. So that is the reason we are charging only 20 rupees per liter for this work. This is only up to 750 metric tons because some of the costs we are putting into our project. But once we complete the project, as I said, there are a lot of cost factors are there. As I said, maintenance of the vehicle and salaries of the people, their DA, TA, everything will work out, and the cost will go up. That's what we are working out on. So whoever comes first, first come, first service. So overall, utilizing the services, we can do this and 20 rupees per liter. Once we complete the project, the later on we are going to work out. Now we had a meeting with the MOF, and we are working out. So depending on the distance, depending on the number of oil. Say for example, suppose somebody is having only 10 metric tons. Say for example, so 10 metric tons means, so 10 into 20 rupees you are getting very hardly nothing. So whether if suppose say for example 1000 kilometers a vehicle has to go and they have only 10 metric tons, then imagine the money what we get and what we spend. We are not able to manage it. So that is why we are working out for kilometers. This is the distance means how much is the oil quantity, and depending on the distance, we are working out a tariff now. So that once is our complete tariff, that will be circulated to all the utilities, all the electricity boards. That is after the completion of the project. So that time, hope definitely this cost is going to go up. Now, right now we are charging only 20 rupees per liter. So with this, so I would like to conclude my lecture, and who are also having any questions, you can please ask me.
Engineers can ask questions.
Hello?
Sir, one doubt is regarding this silicon oil, whether the silicon oil needs any treatment?
No, sir, no, sir. See, this other than any oil, silicone oil, vegetable ester, synthetic ester, they are all non-toxic. Non-toxic, you cannot say, but it is not like PCB oil. It is not banned. Only PCBs are banned.
Sir, how will we identify whether the older transformer is having PCB oil or not, PCB contaminated oil or not?
Can you please louder?
How will we identify the?
That is what. So, if you are having a transformer, if it is very old transformer, sometimes you may not be able to see the nameplate properly. If you are able to see the nameplate, and as I said, there are so many trade names are there. You know that when you're buying an oil, when you're buying a transformer, they will definitely mention there. What is the quantity of oil? What is the oil? Name they would have written. Transformer oil, mineral oil, like that. So if you find out any such names, whatever I gave, and you can confirm it, this is PCB oil. Suppose you're not able to get that also, and if you have the history of the transformer, suppose if it is installed here 1985, then you can always test the standard. We have a testing method. No, we take the oil and test it and find out what is the PCB level, whether it's a ppm, 100 ppm, or 2000 ppm, or pure PCB. We have the method. We have a testing, and we have a equipment called GC gas chromatograph, and we check the oil for the PCB contamination. So you are having any transformer, if you're not able to identify, you can send the sample to us, we will test and give it to you. So this is how we have made inventory also.
Thank you, sir.
Yeah.
Any other questions?
So you can write to me. If you are having my email, you can get it from Sabu sir, and you can write to us, and we are there to help you out. And if you have any questions, hope you all get some information.
Mr. Thomas, can I add? Just I want to supplement something.
Yes, sir. Yes, sir. Please tell me, sir.
Yeah, I am not from KSEBEA. I am a retired engineer, but interested in this subject.
Okay, tell me, sir.
And thank you very much for your informative talk.
Thank you.
But my comments are mainly for power engineers. The one question was how we will find out whether there is PCB or not.
Okay.
This mainly this PCB was used in transformers only for non-inflammability. This is a material which will not catch fire under any circumstances. Even silicone oil, ester, all will catch fire, but this will not 100% is non-inflammable. That is why this was used extensively from around 1945 onwards to almost 1980. This was used, but later only its dangers came out. So this period, mainly this was, for example, I believe in KSEBEA, this may be maximum maybe in hydroelectric stations, that especially old hydroelectric stations, where there is that small auxiliary transformers used inside the power station, near to the generator or turbine. Probably those may have this non-inflammable PCB may be there. So such transformers, especially if it is made before 85, an imported transformer, better to carefully check it. Unfortunately, it may not be even there on the nameplate also, but sometimes they may put a nameplate or some special rating plate will be put that it contains PCB. Otherwise, look at the instruction manual. If it is there, please take caution. Immediately, I try to isolate or replace the transformer or try to see that it is not mixed together. Actually, why this has gone to other items was before 1980, engineers were not aware of the dangers of this material, and the same filter machine was used for this PCB field transformer and other transformer also. That is how it get mixed up or go high ppm in other transformers also. So this can create again problem, and if there is any such incident happened, of course it is very difficult to find out such a, but there is a chance for, if there is a PCB field transformer, there is a chance for other transformers also has high level of PCB content. There is a chance through this filter machine. So that also we have to identify, then take those transformer, isolate it and send it. And power transformers in substations and other places, I don't think there will be any issue, but there may be capacitors wherever used old capacitors in even transformer factories where they use old capacitor for testing purpose. They have the capacitor bank. There also there is chance for PCB field units. So this has to be identified and separated out and inform CPRI and make the. And we must also, as engineers, we must understand how serious this material is, because this will never ever destroy. It will go into the environment, means it can come out and it may affect innocent people. And just like what we are suffering at that Kasargod, no, the same type of issue can come with this. Actually, this was first in a big way found out in Japan, where the fishermen living near a sea, near a river, where they were catching fish and taking they were fish eaters mainly. They all developed a black acne on their body. And this was so painful, and the doctors could not identify initially why this has come. Later, they found out that it is from the PCB. What happened was there upstream, there was a PCB transformer making factory where they were using PCB. And this PCB was leaching out to the ground, and then it went to the river, and fish took it. And from the whoever took that fish, it went into their body, and it will never go out. And then it may create all sorts of problems. So it is extremely dangerous. So as engineers, we must wherever try to identify what all equipments are there, then immediately report to CPRI so that they can take care of this item. Because this, how seriously other countries are also dealing in this item. Just some 20 years back, I just was visiting a factory in near Toronto. It was old GE factory, GE American factory, but then they sold it to ABB. Then ABB was using it. But every rainy season, even after several years, I visited around 2002. So every year, from the US, they will send people, contractors, and they will come and dig and pump out water and take out for isolating or destroying PCB. So that much care they were taking for this item PCB. So it is so dangerous and carcinogenic that we must see to it that this material is not getting into our rivers or into the ground also. Especially old capacitors. The problem is that are all made of thin metal container. Tank is thin metal. After some years, it must be all rusted, and there is a chance for bursting and PCB leaking into the ground. So we should see to it that such capacitors, before getting rusted and causing a leak, we should isolate and send it and destroy it along with other complete capacitor should be sent for destruction or send it to the what he said, Bilai steel plant also, that will be, the danger will not be there. So this is extremely serious item. So thank you, Thomas, for giving this awareness session.
Thank you, sir. Thank you for your input. So, Sabu sir,
Sabu?
sir, is there any other questions I can address? And I hope people have understood the subject.
Of
Yes.
course, we have understood the seriousness also. The Ramayana sir was very elaborate on the seriousness of the subject, the impact on the environment as well as human regarding
Yeah.
this matter. So we hope that our engineers who have already participated in this webinar will communicate with other people also regarding the seriousness of the matter and the
Yes.
contamination issues.
Yes. Yes.
May I now invite whether Sabu is here? Hello.
Yes, I am here.
Yeah, I invite Sabu Joseph to give the vote of thanks.
Yeah. Thank you, sir. Thomas sir is from the CPRI. He has given a very good presentation and an awareness to all our engineers, so that identify the danger of the PCBs. So thank you very much, sir, to giving us your valuable time, and thank you once again. And
Thank
all
you, sir.
participants, thank you.
Thank you so much.
Thank you very much, sir. Thank you. Thank you all engineers for attending the program. Thank you very much. We'll meet the next webinar on next Saturday. Thank you.
Okay. Sir, Sabu sir,
Yes, sir.
so we are also conducting programs, awareness on, not awareness, about transformer oil, no?
Yeah.
So significance of transformer oil. We
Yeah.
conduct one-day training program for all those engineers.
Yeah.
If you want, we can have it in the same way webinar also for your people.
Yeah.
Because this subject, it's about environment and about under IDO project.
Yeah.
And we do that free of cost everywhere because we have to create an awareness. Okay.
Yes,
The
sir.
other one is chargeable. It's all nominal charges for when you go for webinar.
Yeah.
And if you are interested, you can always write to us. Same way we can join. I can ask my colleagues to talk to you on the various subjects about transformer oil testing, what is the new oil, service oil, how to handle it, how to identify a transformer whether oil is okay or not, what is the fault in transformer, what are the case studies, all the things. We have a training program. So if
Okay.
you want, we can have that separately. Okay.
Okay, sir.
Of course, we are
Thanks, sir.
interested, sir.
So you can organize that. Anyway, I thank you so much, sir, for taking so much steps. And finally, we could gather so many people. So I hope everyone is really understood the subject. So if anything, any doubts are there, they can always write to me. So I'm there to support them. So with that, I would like to thank you so much, sir, for taking all the steps. Thank you, sir.
Okay,
Of course,
thank
we
you.
will be in touch with you, sir. We'll contact you for other training programs also.
Okay, sir. Thank you.
We are very much interested in the transformer level service because we are in the power sector. So
Okay, sir.
thank you very much. Thank you very much for the session. Thank you, ma'am.
Thank you, sir. Thank you. So I will leave now.
Okay. Thank you.
Thank you, sir. Thank you.
Okay, thank you.